implementing a Common Telecoms Ontology, CTO, a practical framework for telecommunications data integration. We have with us Arnold Kuersteiner, database engineer and analyst, Point Topic of the United Kingdom. All right, that's Oliver. And Arnold. And over here is Oliver Johnson, CEO, Point Topic, United Kingdom as well. Right. So
thanks very much.
First?
And yes, thanks for hanging around this afternoon. Enjoyed the session so far very much, and I think it's been very well organised. So, in terms of the content and the way it all hangs together. So, congrats to the organisers on that. And we'll try and keep you interested as well. So, just to give you a bit of background on who we are, we're a UK-based broadband research house. It's mostly fixed broadband, but perforce we have to cover mobile as well. We have clients across many domains, obviously mostly ISPs, network operators. Investment is quite popular in the UK at the moment, or consolidation, as it might otherwise be called. Government, academia. But the European Commission is also one of our clients. So for the last 15 years, we've been feeding data into Eurostat. And we're also part of what goes into the DESI, the Digital Economy and Societies Index, I think. So we have an interest in how to integrate our data flows into what's useful across Europe. Despite the recent passing of ways, we're still hoping to be as involved as we can. Part of what we've been learning through this journey is how to handle data better, how companies want to receive it, how to make it easy for them to get the data, to integrate it with their systems, and to get the answers that they want as quickly as possible. And, you know, we I think, have done very well at that. We're the longest running continuous information service, sequentially resubscribed to by BT, by Sky, by a number of the large ISPs and people in the UK. So we're quite proud of our track record in that respect, and 15 years with the European Commission as well. So we're doing something right. And one thing that we come across, as everybody else does, is inconsistent terminology. Sometimes it's because it's helpful to whoever is using that term to be vague or inconsistent about it. So if you know anything about broadband or networks, homes passed or premises passed is a classic metric. And there is not a standard definition, even in Europe, for what a home is, what a household is, and what passed means. So while that's very easy to say, it's actually very difficult to get the exact number out if you ask that question. So what are we trying to do about this? Well, our data is varied, it's cross-domain. I mean, at the very basis, it's about networks and broadband and where it is and where it isn't. But as I just alluded, there are various interpretations and definitions of what the data points actually mean. And they mean different things in commercial and institutional cases, and we get inputs that are labelled similarly vaguely as well. So a lot of our job is to clean data, and I think anybody who's worked in data for a while will still recognise this. 30 years ago, in a way, I'm doing the same job I am today, which is sitting there trying to figure out why this data set doesn't quite want to load, or why the questions come out with weird bits popping out of the corners, and often it's about unclean data or data that isn't well defined. Footprint, overbuild, service provider, all of these terms get used very often and without exactly knowing what they mean. So we're trying to develop a standardized terminology, and Arnold's who's the one who's actually been doing most of the work, will walk you through a bit more about that. Siloization, where more than two people in a room and you get difficulties in communication, more than three people in a company, and the left hand doesn't know what the right hand is doing. So trying to bring this back together so that the accounts department knows what the marketing department's doing, knows what the product development department's doing, knowing what's going on the ground from the actual input from the hand devices that the network engineer, he's dug up this bit and it's gone badly or it's gone well. So putting all those together, back together, because they started as actual objects in the world and they were very well connected. It's only when they come into us and get turned into data that they start to fall apart a bit. And we've been doing this, trying to use various best practices, doubling core, friend of a friend, DCAT, and so on. And actually, just to give you a bit of kind of private sector perspective, it's implemented all of these are implemented very poorly and very badly throughout all the organisations we work with, be they government or private. And this is great in a way. Where there's a problem, there's an opportunity for us, but it also speaks to the inefficiencies that are just rife throughout every decision-making process that you see. And what we try and do, as I said, is make data easier to ingest for the organisations, but also our intention is to make it more efficient and more cost-effective for them to get the information they need to make decisions. So we developed an ontology.
Thank you. Yeah, so that's where we start. We developed an ontology. So I work with a lot of the data of point topic. And when we started this journey, I don't think we actually really wanted to make our own ontology. And I had a good look at what existed already and what was available and what we could do. We are not experts on ontologies or knowledge graphs, but we ended up having the feeling that we should make our own one because there simply wasn't anything that someone with my background was able to understand and use and implement with the data that we work with. So we made an ontology. We called it the Common Telecoms Ontology. It is on GitHub as well. There is a paper that was written about 10 or 7 years ago that we used as a basis for it, although it was a very technical ontology with a lot more terms related to these sort of data standards and data hardware of the telecoms industry, and that's not really the data we work with. Our data is a lot more cross-domain, and it starts off with commercial data and organizational data. So that means the relationship of organizations that provide telecoms to the services they offer at the locations they offer them, and then also over the networks, the specific types of networks that exist that they offer it over. Our ontology is divided into classes, object properties, and data properties, and you see here just an example. So Openreach is a network provider in the UK. It is also a wholesaler, so that's a characteristic of a network operator, whether it is only operating as a wholesaler, so they don't sell to end users like you and me at home. Then we have networks. We have different types of networks, different properties of networks, and different types of relationships to different organizations. And that's what we want to represent here. There are also various hierarchies, especially in the telecoms industry. Well, as in many other industries, it's quite complicated because companies are always buying each other up or going bankrupt or founding subsidiaries or brands, and that's one of the big complications related to our data, where it's quite difficult to attribute a data point to an organization. If there are many organizations you could attribute it to. So you really do need an ontology to kind of capture all of that complexity. So we use this ontology. So it's open source, it's on GitHub, but we use it in our day-to-day work now. We're quite happy with that. It forms the foundation for how we work on new projects. Also, partially with the EC, some of the projects we are working on there, we want to bring this up more in the future because it's also a bigger and bigger topic in the EC, I think. So we implemented it in Snowflake SQL. Snowflake is a private company that hosts cloud database warehouses, and we looked at a lot of different implementations, and some people might be disappointed that we didn't use Sparkle or anything with XML or RDF structures. We looked at that. We also looked at Neo4j. We looked at Amazon Neptune, which is enterprise-grade ontology service from Amazon. But we wanted something quite specific that could have an ontological validation, or could be ontologically validated, but is also available to us in our day-to-day work, and is also, as much as possible, plain text. So basically, we wanted to be able to access a table, be that an entity or a relationship, and actually see the data in plain text. And then we also wanted to avoid the overhead of having to load our business data into another language or syntax, and then having to query it again from another language, because that would have been a lot of overhead. And yeah, we are dealing with quite large data volumes, so millions of rows sometimes. So we just stuck to SQL, standard SQL. Yeah, we use it as the foundation of making new products and projects. Yeah, and we also have an open access version of this. You can think of it like a Wikipedia for telecoms. So just the sort of core of the ontology, the relationships between organizations and where they operate and what networks they have. I'll just show this on the next slide, but we made something for that. So yeah, it's basically a web app. You can see the data that is contained in it. You can go on it if you want. I hope it's not crashed, but I don't think it has. You've got a visualization tool. We had a chatbot, but we took that down because we're working on something more advanced, hopefully. But yes, it's just something where we can sort of put that data out there so that it has a use, because I think this is data that doesn't really exist. There's no source for this, as far as I know, where you can look up the relationship between different entities in the broadband world in the UK. Yeah, the relevance. So this is some examples here of the data that we've ingested. So we've got our own data, lots of Eurostat data, things like households data, Office for National Statistics, so UK household data, population data, income, etc., etc. Lots of technical data from various government and non-government entities, and geospatial information. And so the idea of that is that we can now relate geospatial data points to organizational data points. So for example, you can say, okay, I want all data points, all postcodes, for example, related to the organization. OpenReach, for example, a private organization, in areas that have a certain demographic profile. So that's, we had many different products. We had all that data already, but we never made a system where we can actually correlate that and bring that together. Yeah, so it fills a lot of gaps for us. We also added in integrations with DCAT, so anything that's sort of a document, for example, a news article, because we have a long history of collecting news articles, those are tagged with DCAT vocabulary as well. And yeah, we've got a web app, and the ontology itself is open access, because also we would like some feedback, maybe if one day we get it from other smart people, whether we are doing it the right way and whether there's anything we can improve. So yeah, do we have one more? Nope, that's all. Thank you very much.
I have a couple of questions for both of you. Thank you, Arnold. Thank you, Oliver. The first question on Slido, and if there are any mic questions, let me know. Yeah, please, go ahead.
Thank you very much for the presentation. It's Vasilis Zouvaras from OP. I am a little bit confused. You said ontology, but you didn't use RDF, if I'm not correct. So what's the representation language? What did you use?
So we have the, So we have a schema. So the schema of the ontology is in OWL language. So the definition of everything is in OWL. But we use SQL foreign keys to basically enforce the relationship. So you will have one SQL table for an entity. If you use the sort of RDF syntax of subject, predicate, object, there will be a subject table, an object table, and then the predicate will be another table, which is basically a join between the two.
So you kind of simulated the triple representation in an SQL.
Yeah.
Yes.
Yeah, because we needed something that could handle, millions of rows.
In order
quickly.
to avoid using Sparkle and Triple Store, so you said you want to use your own database. So, okay, clear.
Okay, next question. Is your ontology multilingual, or does it support multilingual data?
Not currently, and no. But yes, we would very much like to extend it with more languages. I mean, we work primarily in the UK, so that's what we've developed it for. But
Okay.
no reason it can't be extended.
Okay. Could you explain how and with which external data sets the CTO is aligned?
So alignment with, by data sets, I assume ontologies is meant, because we wouldn't align our data, we would align the ontology. Yeah?
Yeah.
Yeah, well, we have terms for DCAT, DC terms, friend of a friend, so anything that's sort of related to documents, we try to align to the DCAT ontology. Yeah.
Okay. How are you representing an ontology? What do you expect your world to look at in Snowflake SQL? Why not use RDF for that? I would expect that the instance data would be represented in SQL, but your ontology in RDF. Does that make sense?
Yeah, I think I touched on that already, but yeah, the
Yeah, I
schema
thought so,
itself
yeah.
is in OWL.
Yeah, okay. Any other questions out there? Yes.
Sorry.
Nico?
Yes. In the last slide, you mentioned integration with DCAT and with EU-related vocabulary or something like that. So can you elaborate on that, what you mean with EU vocabulary?
Well, it is mainly DCAT. We've also been looking at adding our ontology potentially to I think was it you who talked about that, the European vocabularies list? We don't really know how to do that, but that's something that, for example, we would like to do if it's possible, and if anybody wants us to do it. But yeah, I guess we just meant DCAT when we said that. Yeah.
Okay, I think that does it. Let's take a coffee break. And when we come back, data spaces, metadata, and cross-border data exchange. So we'll be back at 15:55. See you then.